Okay, 6.1, understanding quadratic functions. We've been dealing a lot with quadratic functions in terms of solving them, factoring, quadratic formula, a little bit of complete the square. Now we're going to take quadratics and graph them. So our essential question is, what is the effect of the constant a on the graph f of x equals a x squared? So we're looking at that a. What is that impact when we change that a value? Okay, so understanding the parent function. So the parent function is a parabola. The vertex is going to be this point right here. In this case, it is at 0, 0. The axis of symmetry is going to be that vertical line. That wasn't very good. It's a little bit better. It goes right through our vertex, and it is at x equals 0. And the axis of symmetry, by term of symmetry, it cuts it in half. It's symmetrical, so it's equal sides of that. And in this case, we have a minimum because our parabola opens up. Now, as we look at our graph here, our domains all are x values. So even though this goes up pretty sharply here, okay, this will continue to go out as we extend this all the way up on both sides, so that our domain, going back to our graph, so the range is all possible y values. So as we look at this, as our graph goes up, it just continues to go up. So there's no limit on the top side. But down here, we have no graph in the negative values. So we have a limit right here at our minimum. That's why it's called a minimum. There's no value that goes below that. So what is domain of f of x equals x squared, and what is the range? Let's go and pause here and come up with domain and range. And a quick reminder, domain, remember, is your possible x values, and range is your possible y values. Going to be all real numbers. Also might see it written like this. Okay, or the way we're going to end up writing this more is in inequality. So we're going to go from negative infinity, which is going to be less than x, which is less than positive infinity, or interval notation, which is negative infinity to positive infinity. Now our range, so then we would state that our range written in inequality would be y is greater than or equal to 0, becomes our y value of our vertex, or written in interval notation, it goes from 0 to positive infinity. And notice on the 0 I have a bracket because we want to include 0. On the infinity, it is an open, it's a parenthesis because you can actually never reach infinity, so it's always an open value, meaning it does not include that value because you can never actually get to infinity. Okay, so some quick information when graphing ax squared when a is greater than 0. So we'd say the graph g of x equals a of x squared is a vertical stretch or compression. So looking at our parent graph, it can stretch it out or it can compress it. So we'd call that more narrow when it's stretched and wider when it's compressed. And the graph opens upward when a is greater than 0. And the function then has a minimum that occurs at the vertex of the parabola. So let's see what that looks like. So here, we have our parent function, which is in blue, and then our new function, which is in red. So as you look at this, our red parabola would be g of x equals 3x squared. So then our vertex is still at 0, 0. Our axis of symmetry, still right down the middle, and that is at x equals 0. We have a minimum at y equals 0. And then our domain is our x values again, and so there is no restriction here, so our domain is going to be from negative infinity to positive infinity, or if you write it as an inequality, you go from negative infinity is less than x, which is less than positive infinity. And then our range is going to go from 0 to positive infinity, or as an inequality, y is greater than or equal to 0. All right, so let's take a look at another one here. So our g of x this time is 1/2 x squared. So now our a is less than 1. It's between 0 and 1. That's why we have that compressed or wider parabola for the red one there. Our vertex is still at 0, 0. Our axis of symmetry, a little off there at the end, but is x equals 0 still. So no movement of where those are at. It is opening up, and so it is still a minimum at y equals 0. Our domain goes from negative infinity to positive infinity, and our range is from 0 to positive infinity. So all that hasn't changed. Even though I changed our a value from 1 to 3 to 1/2, all that changed was the width or the stretch or compress of our graph. But all the other stuff, characteristics, hasn't changed so far. All right, so let's see how we do when we plot one here. So what we'll do is we're going to substitute our x values into our graph. So we get g of negative 3 equals 1/2 negative 3 squared. And that gives us 1/2 9, and then we multiply that and you get 9/2, which is 4.5. And then we move on to the next one, which is a negative 2. And then when we square that negative 2, we get 4. So 1/2 times 4 is 2. And then we go ahead and substitute 0 in. And 0 squared is 0, and 1/2 times 0 is 0. Then we go with positive 2. And just like negative 2, 2 squared is 4. And the 1/2 times 4 is 2. And if you substitute 3 in, you'll see a pattern as well, and it becomes 4.5. That's why we get that shape of that parabola at our vertex. It curves and goes back up. So in this case, our vertex, as we saw in the last one, is at 0, 0 here. Our axis of symmetry is at x equals 0. we have a minimum at y equals 0. Our domain goes from negative infinity to positive infinity, and our range is y is greater than or equal to 0. So writing those in inequality form. And then let me plot these values. So we get negative 3 and 4.5, negative 2 and 2, 0, 0, 2 and 2, and 3 and 4.5. And then there is our parabola for that. All right, so now looking at when graphing g of x equals ax squared when a is less than 0. So the graph of y equals negative x squared opens downward. It is a reflection of the graph of y equals x squared across the x-axis, so it gets reflected down. So when a is less than 0, the graph of g of x equals ax squared opens downward, and the function has a maximum value that occurs at the vertex of the parabola. So now we're going to have graphs that open down, which then flips from a minimum to a maximum, which you'll see on the next one. So we now have our g of x, which is negative 3x squared, which that negative gives us the parabola that opens down. Our vertex, you can see, is still at 0, 0. Our axis of symmetry is still at x equals 0. Now, I have minimum written here, but that should actually say a maximum. And we'd say max at y equals 0. So the location's still the same, but now because our graph is opening down as a maximum, because there is no value for the red graph, our g of x, higher than that 0 point. Our domain is still going to be from negative infinity to positive infinity, because our graph, although going down, will still continue to spread out and pick up every x. And then our range does change. So it's still y, it's still 0, but this time it is y is less than or equal to 0 because our graph is going down. Okay, so as we look at this one, our g of x this time is a negative 1/2 x squared. Our vertex is at 0, 0. Axis of symmetry, x equals 0. Again, this should be a maximum at y equals 0. Our domain is negative infinity less than x less than positive infinity, and our range is going to be y. Well, let me write this one as notation. So we would go from negative infinity to 0 this time. And notice the 0 is on the right, and that is because you always start from your lowest value, which is negative infinity, and go to your highest value, which is 0 in this case. Okay, so let's look at that one as far as plotting it. So we have our negative value. So we go g of negative 3 is equal to negative 1/2 negative 3 squared. So you get negative 1/2 times 9, which then gives us the negative 9 over 2, which is a negative 4.5. And then substituting a -2 in. -2 squared is 4. 4 times -1/2 is a -2 this time. Then this time we have a -1 that we're going to substitute in. -1 squared is 1. -1/2 times 1 is a -1/2, or -0.5. Then substitute 0 in. And you get 0. And as we saw in the last parabola, this all gets mirrored. And so we get -3, -4.5, -2, -2, -1, -1/2, 0, 0, 1, -1/2, 2, -2, and 3, -4.5. We get that graph. Not perfect on applying those points, but you guys see that our vertex is at 0, 0. Axis symmetry is at x equals 0. Again, we have a maximum at y equals 0. Our domain will go from -infinity to +infinity, and our range goes from -infinity to 0. All right, next thing we'll be doing is we're going to be writing an equation given a graph. So we're going to start with y equals ax squared. We want to pick a point. In this case, we'll use this point 2, 2. And so substituting that in, we get 2 equals a 2 squared. And then solving, you get 2 equals 2 squared is 4, so that's 4a. And then divide by 4, and a equals 1/2. So then we would get g of x equals 1/2 x squared. All right, your turn. Go ahead and write your equation. This will be one we'll go over in class, so be ready to answer questions about this problem here. And then don't forget to do your quizzes so you can get the points for those. And then our essential question, check in. How can you use the value of a to predict the shape of f of x equals ax squared without plotting points? All right, so we'll discuss this one in class. So again, be ready to answer questions on this one. Which then brings us to your assignment, which is in 6.1 in your workbook, page 218, number 1 through 13 odd.